Okay, so this video is going to review just the basics of electron configurations and how we create them. So when we do an electron configuration, our goal is to say where each of an atom's electrons are located. So what energy level, what orbitals, and then how many are present there. So for example, if I was looking at carbon, I would want to identify the locations of 6 electrons. Now, when we look at electron configurations, we're going to see two different numbers and a letter. So hydrogen, for example, is the simplest because it has only 1 electron. So its configuration is 1s1. So let's talk about what that means. This 1 here, the coefficient, represents the principal energy level. Okay? The simplest way to think of this, usually it's the period that the electron's located in on the periodic table. The letter here represents the sublevel or type of orbital. And this superscripted number here represents the number of electrons. So the way that I would interpret this for hydrogen is I would say hydrogen has 1 electron in the first energy level, s orbital, 1s1. Let's look at carbon since we already mentioned that. All right, so carbon is right here on the periodic table. Now, before we can write an electron configuration, we have to know about the regions of the periodic table. So groups 1 and 2 here are the s block. So whenever we add an electron in one of these boxes, it's going in an s orbital. And really, helium is part of the s block. Okay? We'll talk about why it's located there a little later when we talk about properties of the periodic table. All right, over here, groups 13 through 18, this is the p block. So when I'm adding electrons here, they're going into p orbitals. Here in the middle, groups 13 through 12, 3 through 12, excuse me, this is the D block. And down here is the F block. We're not going to do configurations with the F block, but it's nice to know where it is. All right, so I'm going to do the configuration for carbon. And whenever I do an electron configuration, I always want to start at the very beginning, and I'm going to go through every row on the periodic table until I get to my element that I'm trying to write the configuration for. And I'm going to say where every electron that I add along the way is located. So I always start here, upper left corner. I'm in period 1 and the S block. So I'm going to start by writing 1s, period 1, S block. All right, now I'm going to keep going until I get to carbon. So I have to ask myself, how many squares or how many electrons am I adding in the first energy level S block? 1, 2, because helium's really the second one, okay? So I would start by writing 1s2. Now, I haven't gotten to carbon yet, so that means I have to go down to the next period or row and just keep going. All right, so now I'm in period 2, and I'm still in the S block over here, okay? So I would write 2s, because I'm in period 2, S block. And then I have to go 1, 2 squares. So I'd write 2s2. Now, I still haven't gotten to carbon, so that means I have to keep going. So now I'm going to go to the other side of the periodic table because I'm still staying in the second row. And now I'm still in period 2, but now I'm in the P block. So now I have to see how many squares it takes me to get to carbon. 1, 2. Okay, so I was in period 2, the P block, and I went 2 squares to get to carbon. So what this means is that in the first energy level, S orbital, I have 2 electrons. In the second energy level, S orbital, I have 2 electrons. And in the second energy level, P orbital, I have 2 electrons. Now look, carbon has 6 electrons because its atomic number is 6, right? And if we add up all these superscripts, they add to 6 because we have 6 electrons. Okay? Let's try another one. Let's look at magnesium. Why not? Okay, so again, I'm going to start at the very beginning, period 1. Okay, so now I'm in period 1, the S block, and I have to go 1, 2 squares. So I'd start by writing 1 S2. I haven't gotten to magnesium yet, so I have to keep going. Now I come to period 2. I'm still in the S block, and I have to go 1, 2 squares. So I'd write 2S2. Okay? I still haven't gotten to magnesium, so I have to keep going. Now I come across, I'm still in period 2, but now I'm in the P block, and I have to go 1, 2, 3, 4, 5, 6 squares. So I would write 2P6. Period 2, P block, 6 squares. I still haven't gotten to magnesium, so that means I have to keep going. Now I'm in period 3, S block, and to get to magnesium, I go 1, 2 squares. So I would write 3S2. And if you add up the superscripts, 2 plus 2 plus 6 plus 2, you get 12 electrons. Okay, in another video, I'm going to talk about shorthand configuration and also about transition metals and how the D block works.